For today, we will be looking at thin layer chromatography, TSC. It is a versatile technique used to separate polar and non-polar mixtures. The experiment is conducted on a sheet of glass, plastic, or aluminum foil, which is coated with a thin layer adsorbent material, such as silica gel, aluminum oxide, or cellulose. TSC is based on the chromatography principle, where mixture components are separated between a stationary phase and a liquid mobile phase by different affinities between the two phases. It is a technique used to check for the progress of a chemical reaction and the purity of a compound. Don't forget to like and subscribe to my channel. Please like, subscribe, and share this video. We can look at the silica gel structure, and looking at the silica gel structure as shown in figure 1, we will observe that it is polar. It contains a network of silicon dioxide with alternating silicon and oxygen atoms at every direction. At the surface, we have many polar hydroxyl groups, which can make dipole-dipole interactions with other polar substances. If we have a polar substance A and a non-polar substance B, we will expect that the polar substance will absorb to the silica gel as it is polar and will move slowly, compared to the non-polar substance that will not absorb but will move with the solvent front. The substances will move at different rates and their RF values can be calculated. The calculation of the RF values was well treated in our last video on paper chromatography. It is important that you watch that video for a better understanding. On this slide, we have the silica gel plates, and we have said that silica gel can be used to dry materials. Preparation of a TSC plate. We use water plus silica gel in a ratio of 1:2 or 1:3. And then we'll add 2 to 3 grams adhesive calcium sulfate gypsum, which is acting as a binder to hold the silica gel to the plate. We mix it properly and stir properly. We coat the mixture onto a glass and allow it to dry. When it is fully dried, we apply a small amount of a diluted sample to the plate on the baseline. We have explained what the baseline is in a paper chromatography. As we apply it, we place the plate in the mobile phase and cover the tank. We monitor the movement of this sample. When it has gotten to the solvent front, we remove the plate from the chamber and dry it. We can use UV light or iodine crystals to view our plates. What are the uses of TSC? TSC is used as an analytical technique used to monitor a reaction. We can also use TSC to select a solvent system from column chromatography. Like we have on this plates as shown in figure 3, the monitoring of a chemical reaction. We'll have the samples that we want to monitor. That is the mixture we want to monitor. We'll take that mixture and we will spot it on our TSC plate. We already know what we are expecting, so we will take 2 other reference samples, A and B, and we will also spot on that plate. As we start the reaction in slide 1, you will notice that the samples are moving from the mixture M it is moving and it is looking as the sample A that we have spotted. And sample B also moved up the plate, but it's not yet visible in that mixture M. So let's sample A that we can see that is shown on that mixture M. Then as the reaction progresses, we'll take another sample of that mixture and then we spot on our plate. As we have spotted in slide 2, we have noticed that we are seeing that sample A, a sample that looks like A, and we have also seen sample B on the slide as shown. We will allow the reaction to progress until it gets, we take it and then we spot again that are shown on slide 3. During the end of that reaction, we will have our spot again. As spotted there, we have observed that A is no more in that reaction, which means that A has completely been removed from the reaction and the sample, what we are seeing now is just B in that reaction, and it tells us that the reaction has come to conclusion. So TSC is used by comparing the spots to the reference samples. We identify the presence of the reactants, the products and intermediates as shown on slide 1 and slide 2. We monitor the disappearance of products as shown on slide 3. We track the reaction progress and determine when it is complete as shown on slide 3. This allows us to gain valuable insight to the reaction kinetics, identify potential issues, and optimize reaction conditions. Are the advantages of TSC over paper chromatography. Separation. It can separate non-volatile compounds while paper chromatography cannot. Equipment is required. It requires minimal equipment and is simple to use. The speed, the components elute rapidly more than paper chromatography. Visualization. It can be visualized under UV light and chemical staining or fluorescence. The detection methods use UV and other chemical reactions. As said, we can spot multiple samples simultaneously using thin layer chromatography. And then it is flexible. It is capable of qualitative analysis and quantitative determination. The disadvantages of TSC. Temperature and humidity can affect TSC. Isomers and enantiomers cannot be distinguished by TSC. The reproducibility of TSC result is very, very difficult. And then for quantification, it is less accurate compared to other chromatography methods, and it requires a careful preparation of plates. We'll say we have come to the end of this lecture on thin layer chromatography. Thank you for watching this video to the end. Don't forget to like and subscribe to my channel. Thank you very much.